So, good lunch, everybody. This is the last issue for the quality, for the workshop. And I would like to present the compliance Eurachem guide, but there is also a leaflet, an aperitif for presenting the guide, which introduces the subject. So in this workshop, we have looked to several of the quality issues for quality in analytical chemistry. And the last point, if a client has an issue, can be decision on results. We can, for example, think of a producer that produces jewelry that will be in contact with the skin, like this one. They want to know if this is leaching nickel. So that is the client issue. And after sampling and doing the analysis, we come up with a result. And then we can compare this nickel release from the jewelry with a limit, and we can take a decision on result. And this is the focus of this presentation. So here is the guide. And the issue here is actually here. We have a measurement result, and we want to know if this, in this case, the nickel release, comply with a specified limit. And if we look at different cases, we have an upper limit in this case, and we can have 5 different cases. In the first case, where the value is well above the limit, and in the last case, where the value is well below the limit, this is not a discussion. These are already set. But the guide is concentrating on case 2, 3, and 4, where we actually don't know if the real or true value of the nickel release is above or below the limit. So we in this guide talk about compliance. But if you look to the ISO 17025, they use the term conformity. Conformity is actually a little broader term. So this guide is only concerned with measurement results that if they comply with a limit. And here we use the term compliance limit. And if a result happens to comply with a limit, we can actually, according to 17025, make statement of conformity. So just to give you some examples, we could have this nickel release. We can also have a toy that is to be used to children below 3 years of age, and we can test for that. We can also have an industry. We deliver or we buy a batch of stainless steel, and there is a specification of the precious nickel between 16 and 18 weight%. We can have a forensic. We can have, for example, alcohol in the blood when you're driving, where there is a specified limit, and we want to be sure that a person has be below or be over this limit. In the forensics example, we really want to be sure, in order to punish the driver, that it is with very high confidence over the limit. In food, we can have, for example, look for pesticide residues in a batch of food. I will actually ask you a question, my friends, now. It's not easy, but I will try, and I hope you can give me the answers in the chat. Because this is a case not covered by the guide. We have manufacturing, so the QC results obtained today, do they show that the process is in or out of control? In this case, we will not look at the uncertainty. We would look at another factor. Is there anyone who has an idea what, instead of uncertainty, we shall use in order to estimate if this result is within or without a normal production batch? Miloslav or David or someone can maybe read in the chat for me. Okay. If
information so far, variance, bias, control chart.
Yes, I think control chart is a good idea.
Intermediate precision.
That's the answer I would like to have. So in this case, when we don't produce something with a certificate, we just look at the production. It's the intermediate precision within lab reproducibility. Thank you for that answer. Let's look at the terminology. we talk about decision rule that describes how we should take into account the measurement uncertainty. And we, of course, have a specification. And from the decision rule and the specification, we can get the acceptance limits or the permissible measured values. That is, the values we get, we can say yes or no directly. So there are several variations. We can have, as in this case A, an upper limit and a guard band. In the case of nickel release, the upper limit is about 0.5. And in order to be sure that you are over the limit, it's 0.88 with the release. But you can also want to be sure that you have a correct acceptance, and then you put the guard band on the other side. We can also have what we normally used to have, simple acceptance. That is, all values above is rejected, all values below are accepted. In this case, we usually provide that you need to set some limit for the uncertainty in order that there will not be too much problem. So, for example, if we test petrol pumps, we usually use this way where I'm working at the Metrology Institute. But of course, we see that we have a very low uncertainty. I will give you an example of simple acceptance. We have the nickel, 16 to 18. We get 16.1. And if we would use simple acceptance, the batch will be compliant with this decision rule. And this is the key. We need a decision rule. And the information needed to make the assessment is a decision rule. But of course, first we need a measurement clearly specified. In this case, we want to measure the total nickel. We want to have a measurement uncertainty for the measured value at the limit, which is in this case is 0.2% nickel. We want a permitted upper or lower limit, which is between 16 and 18. We will need a decision rule, and in this rule, we really want to have very high confidence that we get a nickel value within the spec. And of course, we will have a measured value. In this case, it was 16.1. If we look to an example from the guide, this is example 2, I think. So we talk about the mass fraction of nickel. We have 0.2% nickel as a standard expanded uncertainty. And we have the specification zone, and we have a decision rule of high confidence. And this gives us a guard band and a little narrower zone. So we now have the acceptance zone not from 16 to 18, but from 16.2 to 17.8. So we have a slightly narrower zone. The measured value is 16.1. Well, we are not very confident that it is within the specification. So in this case, the batch will be non-compliant. And you can see the example here. We have the lower and upper limits, and we have a specification zone, and we have a narrower acceptance zone. The decision rule is the key here, and it should give a well-documented method on how to set, as the case of the nickel. We could, from the specification, construct an acceptance zone. There are many types of decision rules in the guide. We have simple acceptance, we have using guard bands, we can also have yes, maybe, and a no. And we can also have a two-stage procedure where we maybe start with the screening and then go further on. It's very important that the decision rule gives a lot of details. Of course, the uncertainty, the assumed distribution. Normally, we talk about normal, but I will come back to log normal. The rounding before assessing compliance. The required number of replicates, and if all replicates should be within or just a mean. And also procedures for dealing with outliers and so on. This is also well covered in the guide. But let's look at the, there is also procedures for further actions. There is a recommendation on how to report compliance. And we also want a recommendation how to state the decision rule. But let's look at the log normal. In this case, we will not have a symmetric distribution anymore, but we will have an asymmetric distribution. if we have a log normal distribution. And usually we'll have that if the uncertainty is high. So here I have an expanded uncertainty of 60%, standard uncertainty is 30, and you can see the limits with a normal distribution and with a log normal distribution. And you can see that the log normal is slightly skewed towards the upper end. In order to calculate the uncertainty interval with the log normal, use uncertainty factor that already Mike has talked about. And I will just give you an example where we calculated the uncertainty factor, where we have a mass fraction of a banned substance in a sample. So here we have a high uncertainty. The URL is 35%, that is the expanded uncertainty is 70. And we will have high confidence of correct reaction. That means that we will put the guard band on top of the. So we calculate a guard band and we have an acceptance limit of 3.6 and the measured value is 3.9 nanogram and it's also accepted. And you can see here a graph of the two distribution, the normal and a log normal. And you can see that the log normal is a little bit tailed to the right. There are examples where you have even higher uncertainty. For example, in microbiology, you usually would use log or relative uncertainty to calculate the uncertainty interval. So this is something we added in the last revision of the guide. There are some other issues talked about in the guide. We have producer and consumer risks. We have decisions rules that provide for conditional or inconclusive results. I already talked about that. And we also have talking about specific or global risk. If you talk about a risk for just one item or for a production over time. We also introduce reference to correct guidance. That is from ILEC and from GCGM, the Joint Committee of Guides. So, summary, the key decision is we need a decision rule. And with that decision rule and the specification limit, we can calculate a new limit where all the values within this more narrow limit are accepted and all values outside is rejected. And the limit has not always to be narrow, it can also be wider. So we used a guard band, and here you see a guard band where you put correct, high confidence on correct reaction, and the B is high confidence of correct acceptance. The upper one would, for example, be used in forensic. The lower one was used in the steel, for example. So we have the different decision rules, and we have this with pass-fail, we have this with guard bands, we have this with conditional, and we have the two-stage procedure. And in order to do anything, we need these decision rules, but we also have some guidance with the introduction of the leaflet and the guide. Thank you very much to all of you for listening just before lunch.